Alright, so here are some actual exam type questions. What I'm going to do is I'm going to do 3 examples for you guys, and then I'm going to send some for you to try on your own. But please do pause the video at any point and see if you can maybe answer it yourselves and then check if you were right. Okay, so what I've done is I've gotten these exam questions and I've blown up the picture just so that you guys can definitely see. So I'm going to read the questions to you and then I'll explain them. So you won't have these questions, but I can send a picture to the group if you like. Okay, so basically, I know it looks quite complicated compared to what I've just done, but I've got the summary page here with our little formulas, and you'll see that the more you answer them, the more you use colors, the easier it will be. Okay, so what I always like to do, and just so you can see, this is how the exam question looks. They always give you a piece of information, the drawing, and then questions. So I like to read the information, highlight anything important, and then answer the questions that follow. So it says in the diagram below, P is 1 and 0. They've drawn that for us. Q is 6 and 3. R is 9 and -2. They're the vertices of a triangle. And you can see this is actually a right angle triangle. PQ is equal to QR. Okay, so what I'm going to do is I'm going to just make my life easier and do this. So I know that those 2 lines are equal. Now immediately, because I just did that, I mean my brain now registers that this is an isosceles triangle. So angle P must be the same as angle R. I don't know if that's going to be useful, but it's nice to know before you even start the question. Okay, then they say that these 2 are perpendicular, and the fact that they are perpendicular should ring this bell in your head. They're perpendicular. When you multiply them together, it'll equal to -1, or you can do that thing where you invert and you change the sign to get the other. If they give you the gradient of one of the lines, you can do that to get the gradient of the other line. So the fact that it's perpendicular should ring that bell in your head. It says T is a point on PQ such that T is the midpoint. Okay, so this is the midpoint of that line, and you have a formula for that. They're most likely going to ask you about what this point is. S is the point of intersection of RQ and the x-axis, sorry. So they're saying that this line intersects x at point S. Now remember, something I didn't mention when I was doing the summary, if it is an x coordinate, what is y at that point? Y will be 0. Remember this, an x coordinate y is 0, and a y coordinate x is 0. Okay, remember whenever you try, and maybe I'll just make a little note of that on our summary page. So x-intercept y is equal to 0, and your y-intercept x equals 0. Okay, so that's important to remember. Alright, what else? It says V is a point on the axis such that QSV is 121 degrees. So they're saying that this is 121, and then they say QPS is theta. They've labeled that as theta. Okay, so let's get straight on to those questions, and we answer them as best as we can. Determine the length of PQ. Leave your answer in surd form. Okay, PQ is this line over here. What do they want? They want length. Length is the same as distance. So over here, sorry, I hope I didn't bump the phone. Over here, we are looking for distance. So I'm going to write my distance formula down. You always write your formula down, okay? x2 minus x1 squared plus y2 minus y1 squared. Alright, so your distance, now we're going to fill it in. you can choose, remember, so this is your line. These are your two coordinates, 1 and 0 and 6 and 3. So this would be your x and that would be your y. Now you can choose which one to start with, but if you make x2 that one, then your y2 must also be that one. Okay, so let's start off like that. Okay, so if I make this x2, which is 6, then x1 will be this one, which is 1 squared, plus if this y2 is 3, then when I minus 0, this one will be your y1 squared. Okay, and then all you have to do is punch that into your calculator. So you can make square root 6 minus 1, close your bracket, squared, plus 3 minus 0, close your bracket, squared. And this gives me an answer of square root 34. Now they said that I can leave it in surd form, so I'm going to just leave it like that. Okay, 1.2, it says calculate the gradient of PQ. So now for this line again, they want the gradient. Okay, so we've just done the distance for it, now we must do the gradient. Now, I know for you guys, you might get a little bit confused between these two formulas, you know when to use which one. But if you look at this, this is theta, right? So they haven't given you the angle, so this one would be a bit useless to use because what would I put there? So I'm going to use the one with the two coordinates because I have the two coordinates. Okay, so your gradient is y2 minus y1 over x2 minus x1. So again, if I start with this one, I'm going to start with that one again. So in other words, if I use y2 there, I must use x2 there. Okay, so y2 is 3 minus your other y is 0 all over. x2 is 6 minus your other x is 1. So what does this equal? It's 3 over 5. So there, your gradient for 1.2 for PQ is 3 over 5. Okay, 1.3, they say calculate the coordinates of T. Now remember I said to you, T is the midpoint, so most likely they're going to ask for that because they like to use all the formulas. So again, look at your formula page. Here it is over here. So your midpoint is going to be x1 plus x2 over 2 and y1 plus y2 over 2. Okay, so your gradient here is going to be x1 is 1, or yeah, let's just say I started here, sorry, I didn't really think it through, but let's say this is x1, x2 will be here, 6 over 2. Then I do the same thing with y, so this will be 0 plus y2 is 3 over 2. And these are coordinates, so I can put them in a bracket. So m is going to be 1 plus 6 is 7, so it's 7 over 2, and 0 plus 3 is 3, so it is 3 over 2. Okay, so that is your distance, your gradient, and your midpoint theorem over there. Okay, now there's still more questions here. There's 3 more questions. I just need to get more paper. Okay, here's some more paper. So the next question is 1.4. Calculate the area of triangle QTR. So I'm going to highlight it just to make our lives easier. QTR. This one over here. Sorry, if you hear any background noise, the matrics are going out for break, so just ignore that. Alright, so it's QTR. They want the area. Now, I just want to remind you, when you're doing area of a triangle, it is a half base times height. And remember, it's always, height is always perpendicular. So if you have a triangle and it's right angled, then that would be base times height. Okay. So basically, you're wanting to say a half this one times this one, or a half this one times this one. It doesn't matter which one you choose as the base and which one is the height. But the point is, it's the two perpendicular lines. So Okay, before we do that, we now obviously need this length and we need this length. I don't know if you recall, but in the previous question, we calculated this whole length, right? And we calculated, or we know that t is the midpoint. So this length must be this whole one just divided by 2. So before I get started, I need to establish this. So TQ is going to be the whole length, which is root 34. And it's going to be divided by 2. So TQ equals root 34 divided by 2. So that'll be 2, 9, 2. Or you can leave it in surd form, but 2, 9, 2. Let's do this. Okay, so that is the distance of this one. Then, you know what, actually, I would prefer you to leave it in surd form. Sorry, I know I'm being difficult now. But the reason I say that is because if I round off this line and then I go work out QR and I round off that line, then when I actually work out my answer, it won't be as accurate as if I left it in this form. So rather only actually ever round off right at the end. So I'm going to leave this as square root 34 over 2. I'll leave it looking just like that. Okay, now what do I still need? I still need this distance QR. So I'm going to have to use the distance formula again, which we know is this. So it's x2 minus x1 squared plus y2 minus y1 squared. All right, so let's go and fill in those points. So these are your 2 points because we're looking for the distance between Q and R. So let's say I start with this x as 6. So it'll be 6. So x2 minus your other x is 9 squared plus, go back to this y, 3 minus 2 squared. Remember, this minus 2 is going to become a plus. So when you punch it into your calculator, make sure you put the plus. So it's going to be 6 minus 9 squared, okay, plus 3 plus 2, close your bracket, squared, which gives me root 34. Okay, so I'm going to leave it, as I say, in surd form, just to make sure that it stays as accurate as it possibly can. So now I can go and do area. So area is a half base times height. So I'm going to say area is a half of root 34 over 2 multiplied by, the other one is just root 34. So your area is going to be a half times root 34 over 2, close your bracket, times root 34. Okay, which gives us 17 over 2, which is equal to 8,5. And you can just, they don't give us a unit, so you can just say unit squared. All right. Okay, we are almost there. 2 more questions. 1.5 says the size of theta with reasons. Okay, so they are asking for this angle theta over here. Now remember, this is an angle of inclination. So do you recall the m equals tan theta? That is when this would be an appropriate formula to use, because you are trying to calculate this angle over here. And we've got the gradient. Remember, m is the gradient of the line. We actually worked that out in a previous question. So it was here. It was 1.2. I'm actually going to do 1.5 here. I think it'll make sense. 1.5. Okay, so we're trying to get theta. So remember, tan theta is equal to gradient, or gradient equals tan theta. It doesn't matter which way around you say it. And we try to get the angle. So we're going to say tan theta is equal to the gradient, which we worked out here. The gradient of this line was 3 over 5. So if we want theta, remember what must I do? I must shift. So it'll be shift tan 3 over 5, which is 30.96 degrees. I hope that makes sense to you guys. 30.96. Okay, we are almost there, guys. So let's do 1.6. It says the coordinates of S. They want the coordinates of S. Remember I told you for an x coordinate, y is 0. Okay, so I'm trying to think of the easiest way we can do this, but a nice way is to work out what the formula for this line is. Remember, when you have straight lines, the formula is y equals mx plus c. You guys did line graphs in grade 9, I'm sure, so I know you know that formula. So it's y equals mx plus c. So we can work out that formula and then we can make y equal to 0. Trying to think if there might be an easier way. Sometimes what people also like to do, and it's not always a great idea, but sometimes they guess. So they'll say this is 6 and this is 9. It's somewhere in between. It looks closer to the 9, so I'm going to go with 8 and 0, if that makes sense. But let's do it the official way. Okay, so I'm going to just get this paper and fold it for us. Okay, so what I'm going to do is work it out the proper way. So y equals mx plus c is the actual linear formula. Now remember, m means gradient. So I'm going to have to calculate gradient, but I have a formula for gradient, which is y2 minus y1 over x2 minus x1. Okay, so your gradient between these two lines, if I start with this y, it's going to be 3 minus that y, which is minus 2, so that will become a plus over the x. So it's 6 minus 9. So m is equal to 3 plus 2, which is 5, over 6 minus 9 is negative 3. So your gradient here is, negative 5 over 3. Okay, and remember, whenever you're filling in this linear formula, I don't know, maybe I should do a revision video on this, but that's your gradient, so that's fine. And then y and x, you can just choose any coordinate. So let's just say I go with that one. Then when I fill it in, your y is going to be the 3. Okay. Your m is going to be what you just worked out, minus 5 over 3. And your x is going to be the 6. Then you can calculate what the c is. Okay, there's actually an easier formula for this. I think I might just send you the easier version, just so that you've got that as well and you can choose which way you like to do it. But yeah, basically let's work that out. So this is going to be 3 equals, so negative 5 over 3 times 6 is going to be minus 10 plus c. Then if I take the 10 over, it becomes plus 10. So it becomes 13. So c is equal to 13. So your formula, your little linear formula, is going to be y equals, your gradient is minus 5 over 3 x, and your c is plus 13. So going back to 1.6, they want the coordinates of s, and now you have the formula. So all you have to do is make y equal to 0. So 0 equals negative 5 over 3 x plus 13. Take your 13 over, becomes negative 13 equals negative 5 over 3x, and then you divide. So you say negative 13 divided by minus, I'm just doing it on the calculator here, minus 5 over 3. So x is equal to 7,8. Okay, so that is your coordinate. It's going to be 7,8 and 0, because y is 0 at that point. I know this was actually a really long way around of doing it. I will actually send you a picture of an easier way to do this. I think I've made it a little bit too complicated. Alright, so let's go on to the last question. Determine with reasons the gradient through line T and the midpoint of PR. So they want the gradient of the line through T and the midpoint of PR. Okay, so that's two separate questions there. Don't know why the gradient of the line through T. Oh, okay, sorry. No. So they want a midpoint. So let's put the midpoint here. Let's call this A. Okay. Then they want the gradient of this line. Okay. So first of all, you're going to have to calculate A by using your midpoint theorem, and then you will get a coordinate. Okay, you have point T because we worked it out here in 1.3. So once you have that coordinate and this coordinate, you can just go use your gradient formula. I'm not going to do that now because I think the video has gone on a bit long. Okay, so I'm going to give you an example to try, example 2, and then I'm actually going to also record a video on it so you can see how I do it.